we will
Os trabalhos
start
com a professora Wanda,
the works with
certo?
Professor Wanda,
Acredito que vocês vão julgar
and I believe
interessante,
that you will find
certo?
this
Ok?
very interesting.
E a palavra passo para a
So,
professora.
I now pass the floor to
Boa palestra,
Professor
professor.
Wanda. Have a good presentation.
Bom dia. Can you hear me? All right. So I'm concerned my voice does not carry easily, and so I wish to make sure that everyone in the room is hearing me all right. So could I see hands if you're hearing? Okay, great. Thank you. I wish to begin today by saying to Professor Edson Barros, thank you so much. I know he has worked many hours over many months to arrange the ALICE Congress here in Sao Paulo. This is my first visit to Sao Paulo and my first visit to Brazil. And I am so thoroughly impressed. I feel so welcomed, and I just want to let each and every one of you know that the smiles on your faces and the warmth of your greeting is so heartwarming. And Professor Edson, thank you so much for what you are doing to help bring ALICE to Brazil. And I am so grateful for your real concern for the children in your country. One of the coincidences is that Professor Edson informed me on Sunday that President Obama was also here in Brazil, and I was absolutely certain that had no connection to to why I was here, but it did seem to be a good sign that the spirit of cooperation between our nations and the spirit of collaboration between Professor Edson and Mackenzie University with the ALICE Project and Carnegie Mellon University seem to be in good company. I am the director of the ALICE Project at Carnegie Mellon University, and I am trying to step into the shoes of a very famous man, and there is no such thing. It simply cannot be done. I will talk with you this morning about the history, a brief history of the ALICE Project. This afternoon, I will talk with you about ALICE 2, which is currently in version 2.2. Then tomorrow, we will have a guest speaker using a Skype connection to allow us to communicate with Dr. Stephen Cooper, who is at Stanford University and is a member of the ALICE Project. has been a member of the project since we began the Alice Project. Then in the afternoon, tomorrow, I believe is the afternoon, I have not memorized the agenda. We will have a presentation on Alice 3. I believe, perhaps I have those reversed.
Time to update the agenda for Wednesday.
Nós vamos fazer na quarta-feira.
What we will do on Wednesday will basically be the following.
Na abertura, nós vamos ter uma
At the
palestra
opening, we will have a presentation by Jorge Franco from Febrace.
Depois, no período da manhã, professora
In
Wanda,
the morning period,
vamos ter
Professor
a
Wanda,
agenda,
we will have
será sua fala, o Alice 3.0.
your presentation about Alice
Nós
3.0.
tínhamos agendado o Skype na segunda
We
parte da
had
manhã.
scheduled Skype for the second part of the morning,
Há uma questão de fuso horário,
but there's a time zone difference.
né?
The professor is in California, and he would have to wake up in the very early morning. So we invited him to speak during the first half of the afternoon. And all the other events continue as normal. And I apologize for that because it was my bad for not having said this before.
Obrigada. My Portuguese, Poco. Okay. So I am also most grateful for the translators who are here and helping me understand what's said in Portuguese and hopefully helping you understand what I'm saying in English. So my thanks immediately to the translators who've been doing a terrific job already this morning. All right. Let me invite you to please be sure to fill out the survey form. On that survey form that's in your packet are questions that will help Dr. Edson as he enlists support for future Alice project work. So your feedback is greatly needed. And you will receive in compensation a thumb drive. And on that thumb drive, you will find both Alice 2.2 and Alice 3. You will also find a copy of software known as NetBeans, which is a Java interactive development environment, an IDE, and that is used with Alice 3. I will talk extensively during my presentations about what Alice 2.2 does and the intended audience of that software, as well as Alice 3, and we'll explain why NetBeans is there and what your interest might be in using that software. Of course, I cannot possibly anticipate what other needs you may have, and so I have put on this title slide the URLs for web pages that can provide additional information and updates on the software that's on those thumb drives. Alice.org is our main page for the public in general. At this page, you find the downloads for the software. You find announcements of the latest events involving Alice, and on the home page of Alice.org today is a link to Alice Brazil. So a great deal of effort and work has gone in to maintain collaborations such as the one here in Brazil. We are so pleased to be here and to welcome you to the ALICE community. We also have a second site, and that site is aliceprogramming.net. Right now, that site is set up for use by teachers, by professors, and this has all of the instructional materials that we have prepared for ALICE 2. And it is, some of it is public for anyone who wants to visit and see some of the instructions there. But most of it is password protected. And the reason for that password protection is basically because it has the answers to the questions and the exercises, and it also has a test bank. And so you need to be an instructor, a teacher, a professor to obtain a user ID and a password. The exercises and the test bank and so forth are designed to go with our textbook for ALICE 2. We are currently working on aliceprogramming.net to update it so that it will also have instructional materials for ALICE 3. At this point in time, ALICE 3 is not a replacement for ALICE 2.2, so that's why we need two separate sets of instructions, and they are intended for two different audiences. As I said, I will elaborate on that and provide greater detail. So with all of that preliminary information, please allow me to talk with you about the development of the ALICE project. I promise to try not to be too boring, right? The sponsors of the ALICE project have been very generous to us. This is why the software can be free. And without the generous support of these companies and foundations, we would be charging about $500 per copy for ALICE. And so we are so grateful that every time I give a presentation, I want to put their names up there, and I want to say thank you. I can sleep at night because I'm not worried so much about where the next paycheck is going to come from for the people who work so hard for the ALICE project. That said, I will start not sleeping at night about a year from now if I don't get further support. But these companies have been so generous to us, and in particular, I would also like to say thank you to the university, Carnegie Mellon University, because we are a nonprofit group. And we do not bring a great deal of funding into the university as many projects at Carnegie Mellon do, but the ALICE project does not. And so they have been so supportive that I think they need a special word of thanks. We are a very small team. We have two major sub-teams. Our organization on the left are the teachers, the professors, and that includes myself. I do teach, and Don Slater, who also does teach, and Steve Cooper, who also does teach. I and Don are at Carnegie Mellon University, obviously, and Steve Cooper is at Stanford University. In the right is Dennis Cosgrove, whom you saw mentioned in the great video that was shown by Professor Edson at the beginning of the Congress today. Dennis was a student of Randy's about 20 years ago. So he has been with the project for a long time. He is now our chief architect and our lead software engineer. Dave Solba, also a previous student of Randy Pausch's, and he is our second in command in the software development team. Gabe Yu and Clea Schuler, they provide us with the technical and professional assistance. So that's our team, and it's very, like I say, very small, but we work very hard. I'll tell you a secret. In my office at Carnegie Mellon, there is a sofa, a couch, and it's a long one, and it has a pillow and a quilt, and the software developers often work until 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock in the morning. And in Pittsburgh, we have winters with ice and snow, and they are under instruction not to get in their car and try to drive home in the middle of the night when the roads are covered with ice and snow. They are to go in and go, sleep on the couch. And the reason I tell you that story is because I want you to know how hard they work and how many hours they put in. They're not required to be there 10, 12 hours a day, but they often are. They work very, very hard on this project, very devoted to the project. In the video that you saw this morning, there was there were some quotes about Alice and about Dr. Randy Pausch. I do want to start the story there. In the early 1990s, Professor Pausch had finished his PhD. He was working at the University of Virginia. His realm of investigation, his research, was in virtual reality. Now, virtual reality, as you can see in this photo, was at that time in its infancy. So this was a new realm of research, and it was for the purpose of creating an immersed environment. That is, you would put on this head-mounted device, and you might have sensors on your fingers. Some used gloves, others used little pieces of wire and metal that attached to your fingers. Some, as you see in this photo, used a sensor that was in sort of a wand, and suspended over your head was this big disc that detected the motion of that wand. Now, the idea was that by putting on this head-mounted device with the goggles, you couldn't see anything else. And so what you saw in that head-mounted device was the virtual world. Virtual in that it didn't really exist, but in your mind, that seemed to be where you were. If you saw the movie Avatar, yes? Oh, I went twice. Okay? And I thought, I will never be able to get on a spaceship and travel to another planet. I think that will happen, but not in my generation. I hope in your generation. But because I will never be able to do that, I felt Avatar was my opportunity. I went back a second time to experience it. I just felt like I was there. You know, you could see the little things that I can only imagine as something like pollen. You know, the little floating things. They were just like I could reach out and touch them. It was so great, and that's the way it is when you put on this head-mounted device. It feels like that. But unlike in a movie theater where you can see around you and you know there's other people sitting next to you, when you've got that head-mounted device on, that's all you can see. All right? Randy's realm of research was in providing the video, the animation that you see in that head-mounted device. All right? About 3 years into his work at the University of Virginia, he had the opportunity. If you read his book, The Last Lecture, you know it was something he had to strive for. It's not like it was just handed to him. But he made the opportunity for himself to go to the Disney Studios in Orlando and to work as a Disney Imagineer. And this, this scene that you see is where he was working at Disney with the head-mounted device. And what you see on that screen is what he is seeing in the head-mounted device, so that and you can see all the cables and this sort of thing that are attached, and he's sitting on a machine that is intended to work somewhat like a motorcycle, except that it's stationary. So kind of like being in a fitness center, except there were really no pedals, so you weren't really cycling. You were just sitting on this machine, but it does have some devices attached to it that are rather unique. This is the finished product. When you sit on this machine, this is called the Aladdin ride at Disney Quest in Orlando, Florida. And it's still there. It still works. I have been on this ride at least 6 times. I don't want to admit any more. Okay, but the ride is rather fabulous. You sit on this thing that's kind of like I say, it's kind of like a motorcycle, but instead of having pedals that you pedal, you've got this steering device. It's not a steering wheel. It's more like a wing, like wings on a plane, and you can actually take it and tip the wings left and right and forward and back. All right? Now, I really, really wish I could show you this ride. This is a photograph of that was part of the paper that Randy Pausch and some of his students published as they were working on developing this ride at Disney. Now, because we're not there right now, what I'd like to do is to help you experience this ride, okay? And I happen to have a very rare video. So what I want you to do is I want you to pretend that you are sitting on that ride that you have that head-mounted device on your head, all right? And will you ride with me on the magic carpet, all right? Okay, you ready? Yeah?
Complete with headset and goggles. Now, the goggles inside are actually 2 high-resolution monitors. Show them there, Phil. They're slightly offset for a 3D effect. And, of course, the headsets are built right in.
Now, once you've got them on, you control the carpet by grasping the edge, which allows you to then dive and climb and bank and turn, and you take a cyberspace flight through the city of Agrabah. It's great.
Built with Silicon graphic workstations, the computer program takes you on a 3D magic carpet ride through Aladdin's world.
It took 4.5 years to create the 3D models and animated characters you interact with, and the Disney Imagineers have written their own software incorporating breakthrough techniques for texture mapping, real-time computer animation, and 3-dimensional sound.
Oh, find another street, you!
This is fantastic.
Great. There are 4 platforms, 4 magic carpets, each requiring 512 megabytes of RAM.
Don't you have a horn on that thing?
This is really something. Aladdin's magic carpet is still a work in progress, but it is open to the public, so if you're heading down to Walt Disney World, check it out, and find out what the Imagineers are doing. If you're lucky, you might get a chance. Complete with headset and goggles. Now, the goggles inside are actually 2 high...
So there, that was your ride on the Aladdin head-mounted device, the magic carpet ride, and this is what Randy and his students worked on when Randy was part of the Imagineering team at Disney. Now, the interesting thing about this. Oh, by the way, I really should give credit to the Discovery Channel because that was part of one of their programs in 1995. And as I said, this was being done in the mid-1990s, early to mid-1990s. Part of what happened when Randy returned to the University of Virginia is that he wanted to bring this experience of working on virtual reality into the classroom and use this with his students. As it said on that video that you just saw from the Discovery Channel, they use Silicon Graphics workstations to create the 3D animation. The problem is that a Silicon Graphics workstation in 1995 was approximately $25,000 US. If you have a classroom of 50 students and you want 50 of those machines for your students to work with, you have a huge budget. And that doesn't that doesn't include the amount of money it takes to do the to put the software on there. So what Randy wanted to do was to come up with a way of creating this 3D animation very similar to what he was working on at Disney, but to put it on a reasonable budget for a professor at an academic institution to have $25,000 machines was just not within reach, no matter how good you are at going out and raising funds for your research team, and he was very good at that. It's still a very expensive proposition. So what he did when he came back to the University of Virginia was to establish something called the Stage 3 Research Group. And then he worked with the students, including Dennis Cosgrove, to create software that would run on an ordinary computer, not some big, very special, very powerful Silicon Graphics workstation, but on a standard kind of PC. And so this is what the Stage 3 research group worked on for several years. During this process, he was offered a position at Carnegie Mellon University, and he took that position. He took along some of his students from the University of Virginia. He felt very responsible for students who were working with him, so he took them along with him, and he established what you see here. This is Randy's lab at Carnegie Mellon. So this is Stage 3. And I think that that's Dennis in the room. When I first visited Carnegie Mellon, this is the room I walked into. What a thrill to walk into a research lab where there are stuffed animals hanging everywhere, where imagination is all around you. It was a thrilling, inspiring experience. The software that they developed was known as ALICE. I'm often asked, what does ALICE stand for? And what I often see is people write ALICE in all caps, as if it were Fortran or some other programming language where the letters like BASIC stands for basic, all-purpose, and so forth, and Fortran was formula translation. ALICE is none of those things, all right? It was named ALICE because in the book Alice in Wonderland, Alice falls asleep. I mean, the author didn't exactly say she had fallen asleep, but we all know that's what she did, right? And she dreams of this virtual world where she falls down this rabbit hole, right? And this virtual world is populated with all kinds of strange critters, and they seem to act rather funny. And she is presented with a number of logical problems that are very mathematical, and she has to resolve these logic puzzles. And so that's why this software is named ALICE, because you can create your own virtual world and you can populate it with all kinds of strange critters. And you can tell a story and you can solve logic puzzles. And you can play games. And it's just very stimulating to the imagination. That's why it's called ALICE, all right? Just don't fall asleep when you're using it, okay? All right. When I first saw ALICE, that was the original ALICE. That's ALICE 1, if you will, all right? When I first saw the original ALICE, I put on a head-mounted device. I had in my hand a wand, and over my head was this big sensory disc to track the motions of that wand. What I saw inside the head-mounted device looked like I was in that space capsule in Star Wars, where Luke Skywalker has a lightsaber, and there's a little robot, training robot that's floating around the air, yes, and it's going here and there and there and wherever, and I could see the light from the lightsaber, and everywhere I moved the wand in my hands, that's the way the lightsaber went. And my goal was to try to get the lightsaber to make contact with this floating robot trainer. Yes? Now, if you ever saw the first version of Star Wars, the first film of Star Wars, you probably remember that scene. It was absolutely exciting to me. And after about 30 seconds, I said, ooh, I know what I could do with this. Because you see, I had just finished a PhD. And my PhD was in using visualization in programming languages. And I was applying it to creating visualizations in a programming language for the purpose of teaching students how to write computer programs. Now, I had created a software package named Grok, G-R-O-K, and I wish I knew the Portuguese pronunciation of those letters. But Grok means to understand to the depth of one's being. And so it also stands for Graphic Representation of Operational Knowledge. It's kind of boring, but I like Grok because my goal in creating that software was to help my students understand, not just enough so they could pass an exam, but enough so it stayed with them the rest of their lives. At least those fundamental concepts of logic and reasoning and how to solve problems and how to organize things so that they work well. And I wanted those concepts to go with them out of the classroom and stay with them. 20 years from now, they might not remember all the little details of my class, but hopefully they would still remember and be using the concepts of problem solving and logical reasoning and algorithmic thinking that I was trying to convey. Grok used what is called imperative programming concepts. And for those of you who may not know, imperative programming languages are languages like C and Pascal. And unfortunately, right about the time I was finishing up my PhD and I was defending my work with Grok, things were changing in the mid-1990s. What was going on was something called an object-oriented revolution. Programming languages were changing from the imperative languages, which they had been for about 20 years, well, about 15 years perhaps, into an object-oriented paradigm. And the programming language at that time that was becoming very, very popular was C++, and there was another programming language that was new, just on the horizon, and it was called Java. And Grok was now going to be outdated before I even got it out the door. And now I'm standing with a head-mounted device on me, and I am looking at the answer. I needed to redevelop Grok into an object-oriented language, or I needed to talk with someone named Randy Pausch. And I did. I talked with Randy, and I said, you know, I know that your research area is virtual reality. My research area is visualization in programming languages. I think you could help me. And so he listened to me, and we pulled in Steve Cooper, who is a semanticist and works in a programming language semantics, and we talked about what we might do with the existing Alice and with our desire to create a tool like Grok, but object-oriented like Alice. And so that was the beginning of a collaboration where we proposed to take the Alice that Randy had and adapt it as a program visualization environment for teaching and learning computer programming. So what was the motivation for our getting together? Well, I had just finished up my PhD work. I was working my first year at Ithaca College in upstate New York, and I was very much aware, had been aware for some time, of the high dropout rate that we experienced in the first year of computing courses and informatics kinds of programs. Just so, in case you don't know, this is not unique to the United States. This is a global phenomenon that in the first year of study as a computer science major, as a computer information technology major, as an informatics major, that very, very first year, we would typically lose anywhere from 30% to 70% of our majors. Now, it is not unusual for students to change their major, all right? But typically, it doesn't happen that fast, and not in the very first semester or the very first year. It was also the case that as I looked around my classroom, I found that in a class of 20 students, I would have 18 males and 2 females. I found that very disturbing. Not that I don't like guys. I like guys. Okay? But I also am very much of the feminine persuasion. And I also am aware of the fact that young women today often do not stay home to care for their children for 20 years. They often have their children. They stay home until the children go to school, and then they go back to work. And it was disturbing to me that some of the highest salaries are in the field of computing. And not having young women there meant that these young women were not eligible for high-paying jobs. That bothered me, because I think young women should, have future careers that are as exciting and that give you financial support equal to that of the young men. All right, so there you go. I wanted greater diversity. I was also concerned by the fact that in my classroom, as I looked around the room, I had no people whose complexion was not white. That bothered me greatly. So I wanted greater diversity, and I wanted to improve the retention rate of students in that first year. I wanted to do a better job, so I started talking with my students. And I said, when they would come in and tell me they were going to change their major, I would say, why? Is it my teaching? I got to tell you, I think I'm a pretty good teacher. All right, so I was hopeful that was not the answer, but I wasn't always, I wasn't the only teacher. There were lots of other teachers in computing, so I didn't think it was totally my fault. So I asked, and what I found out was, here is what a typical student said to me. Look, I thought I was going to learn how to write video games. I figured by about the 4th or the 5th week of the class that I should be able to write something, well, like at that time it was Doom. All right? They thought they should be able to start writing video games about halfway through their very first semester. I realized that we had a generation gap. Because you see, when I learned to program a computer, my very first program that I wrote was in Pascal, and it was all of about 7 lines of code. And when I tried to compile it the first time, I had 63 errors. No kidding. I remember that number because it was such a shock to me. I do remember that, all right? And I was lost. I was sitting in a room where there were several other students, and the computer in the room, just to tell you the truth, the computer was in a back room. I'm sitting at a little terminal kind of thing. And oh, by the way, there was no monitor. It was paper. All right, paper came up through, and when we typed, you saw the characters on the piece of paper. No graphics. All right? But, I didn't have a teacher to turn to. There were no TAs in the room, and it's like 7 o'clock at night, and I have 2 children and a husband at home. I needed to get rid of 63 errors. Fast. All right? Very frustrating kind of thing. And I finally figured out that I had forgotten to put the semicolon at the end of the very first line. And from there on, the computer did not understand a single character. So there must have been about 62 characters from there to the end. All right. But once I put my semicolon in, suddenly I had 1 syntax error. Now, I'd have to say, when I got that to work, I could have gotten up and danced around the room. I was so excited. And you know what it did? It printed out "Hello World" on paper. But it was exciting. Now, I have a student in my office who's telling me he's going to change his major because he's not able to create video games about the 4th or 5th week into the semester. That's called a generation gap, right? Woo! So I'm like, whoa. So here's the thing. Today's students, and that includes all of you who are students in here today, walk around with wires hanging out of their ears. Yeah? They've got a cell phone in their pocket or their book bag. They can open up that cell phone and they can send a text message that says "Hello World," and they can literally send it to the world in about 12 seconds. And they see absolutely no reason for writing a program that prints out "Hello World," even though it's on a monitor. All right? No reason whatsoever why it should take them an hour of work and 7 lines of code and frustration with 63 syntax errors to print out "Hello World." And you know something? They're right. Absolutely right. What has to change is how we teach these students. That was my conclusion. And that was the reason for Grok. And it was my reason for talking with Randy Pausch about the original Alice. And it was my reason for saying, here's what I want to do. Now, this gentleman is a professor at Carnegie Mellon University, which in my mind is like, you know, one of the best schools in the entire world. And he has a budget well over $1 million a year. And he has PhD students. And here I am like less than 1 year out of my PhD program. I'm teaching at Ithaca College, which I got to say is one of the best colleges ever. And I loved teaching there. And he didn't know who I was. Nobody did, except my own children. All right. And I'm coming in telling him I would like to have permission to take his software and modify it. All right? And this is what I'd like you to know about Randy Pausch. And that is that he listened carefully to his students, to his colleagues, and to somebody crazy like me. And after some consideration and some talking, he told us why he was interested in our idea. Here's why Dr. Pausch was interested in our idea. At the time that I was talking to him, which was the late 1990s, we were beginning to experience a drop in enrollment in computer science. Randy was very, very perceptive, and he was aware of the fact that this was just the beginning in the late 1990s. It was just the beginning. He anticipated that over the next few years there would be a large drop. This graph that you see shows he was right. This graph was put together in 2006, and I have to tell you that in the United States we have only recently begun to recover. This shows you the number of students coming into American university and college level programs in computer science and computer information systems and informatics, all of these things, and how it has just dropped. And like I say, it's only begun to just sort of level off in the last year or so. I would like to think Alice has had something to do with that. I have no proof. Well, I have a little proof. All right? But this was what Randy was looking at. What he showed me was something very similar to what you see here. This actually is more recent data than what Randy and I had in the late 1900s, but we were already, 1990s, but we were also seeing this trend develop at that time. These are anticipated jobs. What I have outlined in yellow, these are the anticipated jobs between now and 2000. I believe this is for 2018. All right, so that's what, 6 years, over the next 6 years. We are anticipating this sort of increase in jobs. As you can see, approximately, put my glasses on to make sure I'm saying this right, we are anticipating an increase of about 70% in the professional informatics, technology kinds of occupations. We are anticipating about a 25% increase in engineering, about less than 5% in life sciences, not including medicine, and about the same amount increase in the physical sciences. All right? Now, if we take a look at the anticipated graduates during the same amount of time, all right, you can see, and now I have shifted the little yellow highlight boxes to how many students we anticipate to graduate with degrees in these areas. We anticipate to graduate about 25% more in the computing sciences, about 33% more in engineering, 35% life science, and about 6% physical sciences. Now, if you put those two together, it looks like this. Quite clearly, we are doing a really great job in the United States with engineering, with life science, and with physical science. What's happening, however, is in the computing sciences, we've got a problem. Now, let me also tell you that people in my generation are getting ready to retire. Yes. 2 weeks ago, I went to talk with a financial analyst. All right? Can I retire in however many years? Okay? What do I have to do between now and then to get my retirement in order? And other people my age and younger who are in their late 50s and early 60s are really looking at retirement very soon. What's that going to do to these numbers? So this is what Randy was motivated by. He was very concerned about the fact that we have a gap. We have a coming crisis in the United States. I understand from Professor Edson that you too are going to have a crisis because you're not producing enough computing and engineering people to fill the jobs that you know are going to be there because Brazil is a developing, you are developing the status as a global economy. You are participating in the growth of the world, and you are attracting companies, and those companies need to hire people who are well trained. Obviously, we need to work together to meet this demand. And ALICE is designed to help meet this demand, and I will talk about how we intend to help meet this demand. So, what Randy said was, I'm not going to give you software, ALICE, which is for virtual reality, and send you away to do this on your own. What I would like you to do is to join Stage 3. We will take some of my people and we will have you work with us, and we will create a new team. This new team will be called the ALICE team, and we will take on the challenge together for a new vision for ALICE as a gentle introduction to computer programming. and we will use not the virtual reality, right, but virtual worlds that run on a typical PC. And the reason for that is that essentially what he had done with Alice was to put it onto a PC. We would work with it to take it out of the head-mounted devices, however, which were also expensive and not readily affordable by students in the ordinary school. And so this is what we did, is we got together. Our first meeting in working on this was in 1998. All right? We released Alice 2, the successor to the original Alice. All right? Actually, a modified original Alice. In 2004, we put it out in beta form, and in 2005, finally, we released it in full release. So people say to me, well, how did you make Alice such a success? It's such an overnight success. And I'm like, well, it's not an overnight success. It only took us 7 years to get it from the drawing board to release. Now, we have been working on Alice 3. Alice 3 is tackling a very different job, which we will talk about later. And Alice 3 was begun in actuality in late 2008. We suspended operations for about 6 months while Randy was struggling with pancreatic cancer. And so the real push for Alice 3 did not begin until late 2009. It is now 2011, and so we've really been working on Alice 3 for about 2 years. That's not enough time. Alice 3 is still in beta. And people would very much like us to just shove it out there. Well, we put out the beta, and we are updating it, and we're working on it, but it takes time. This is high-tech stuff, and it just takes, and we're a very small team, and I don't care if they do. Well, I do care greatly. They work until 2 o'clock, 3 o'clock, 4 o'clock in the morning. It's just very, very difficult time-wise, and it certainly took many years to get Alice 2 out the door. We expect to get Alice 3 out in half that time. All right? So, we adapted the original Alice system to become an educational tool. This would allow students to learn computer programming more easily. We came up with a drag and drop editor, which prevents that 63, 67 errors at the very beginning. All right? You cannot get syntax errors with a drag and drop environment. It just automatically creates the statement, puts all the semicolons, parentheses, quote marks, etc. in exactly the right places for you. And the programs that you create are 3D animations. And so, folks, you cannot program Doom the 4th week of class, but you can get pretty close. You can create some games, you can tell stories, you can create 3D films that are very much like what you see in Disney and Pixar kinds of animations. Not quite so fancy. All right? But it's free. It runs on a normal PC. It now runs also on the Mac. It runs on the Windows Vista and now the Windows 7 operating systems. It runs on the Mac OS X. It even runs on Linux. All right? We believe it provides high motivation for our students. It is not only free, but it is also open source. And so this is where where we were headed. Our first version was called Alice 99, all right? And Alice 99 was actually using Python, and you had to type in the code. So this is before the drag and drop. It's no longer available. It wouldn't work even if you put it on your machine. I tried. I was going to try to show Alice 99 before the drag and drop environment, but can't get it to run without messing up a lot of other things on my machine. Where we are right now is we have Alice 2.2 and Alice 3. Now, actually, there is a third environment called Storytelling Alice that was developed by Dr. Kelleher when she was a PhD student with Dr. Pausch. Storytelling Alice was specifically for Caitlin's dissertation work, and she has now accepted a position at Washington University in St. Louis, and she is working on a subsequent version to Storytelling Alice. It is called Looking Glass, and Looking Glass is targeted at informal education. Alice is targeted at formal education. And Looking Glass is not yet ready for release, but then neither is Alice 3, really. Looking Glass is built on the Alice 3 engine. So we are working closely with Caitlin on her work. She has many other projects going as well, but she is continuing to work on that. I put this here because you are university students, professors, and interested in the classroom environment. And that's what Alice 2.2 and Alice 3 are for. And that's what I mean by formal education, is in the classroom with teachers and students in attendance. They have two very different target audiences. Alice 2, now in version 2.2, is really targeted at the audience from about grades 9 through maybe first year in college. And that was our original target audience. If you have students who are gifted and talented, you can use Alice 2 down into the middle grades, such as grades 6, 7, 8. All right. But it was originally targeted for high school students. Is that the right phrase? Okay, high school students and first year college students who had no previous programming in high school. So it was originally aimed at students aged, say, 10 to 20. Now we label it at 10 to 18 plus. Why? Well, because we're finding that Alice 2 is being used by people in what we would call senior citizens classes, people who feel very challenged by computing technology because it was not part of their generation as they were growing up. They are finding that Alice 2 is helping them understand. The materials that have been prepared to work with Alice 2 are for what we would call intermediate computational thinking, introduction to programming, what we would call, we call it pre-CS1. CS1 being the first year of college. So preparing students for college is what it's really intended for. But as we say, we have many, many, many professors at four-year colleges and two-year colleges who are using ALICE because about half of their students coming in as freshmen have not had programming in high school. And what happens when you put students who have not previously had computer programming in the same class with students who have, then what you're doing is you're creating a situation where those students who have had previous programming are always ahead of those who did not have programming in high school. So ALICE 2 is being used to kind of close that gap, to provide college-level, introductory-level course to help students prepare for that rigorous CS1 kind of course where the pace is very fast and some assumptions are made about background. Now, ALICE 3 is actually being prepared for upper-level high school and definitely for college level. So the ages we are assuming for ALICE 3 are 16 to adult. So this is an evolution. It is not at this point in time correct to think that ALICE 3 is a replacement for ALICE 2. That is just not the case at this point in time. Eventually, we may have the resources to work on ALICE 3 to provide multiple interfaces so that you, or at least options, such that you can choose certain options that will give you an interface that's easier for younger students to use. Right now we have some of those options, but not enough of them implemented to make that claim. And so this is really where we are. Now, what I did and what Randy did in our collaboration was, Randy was the software development director. Steve Cooper and I were members of the ALICE team, and we did not actually write code for ALICE, but we worked with the development team as the curriculum experts, as the computer science educators. It was our responsibility to develop the teaching methodology, what we would call the pedagogy. All right? So I was the lead for the pedagogy team, and Randy was the lead for the software team. The approach that Steve Cooper and I developed for teaching with ALICE is called the ALICE teaching approach. Not too clever, but very descriptive. All right? It is a blend of traditional problem-solving techniques, designing with storyboards that we borrowed from the animation film industry, and program visualization, which is what I worked on as a PhD student. That was my dissertation research work and the specialty that I have researched ever since. This teaching methodology is now being used in many different kinds of courses in the States. One is a pre-CS1 or programming logic course. This is most popular at the late high school, early college level. It's particularly used in two-year colleges in the United States, where we have many students who come in having lost their jobs, especially in the recent economic downturn. We had a very high unemployment rate, And many people lost their jobs, and then when they went back out to try to find a new job, they found they didn't qualify for these new jobs, and so they've had to go back to school. And the two-year colleges are a great place for doing that. And so they get a lot of what we call returning students. And so this is a very popular place for this kind of pre-CS1 course, because most of these people did not have a programming course in high school. When they went to high school, there was no such thing. We also have people who use this as a conceptual introduction the first week or two in a CS1 course at the college level. That has turned out to be rather problematic, and that's what ALICE 3 is working on. It's used in an introduction to programming course for non-majors, for people who are other majors, for engineering students, for biology majors, for biochemistry majors, for chemistry, physics, and so forth. One of the things we're finding in the marketplace is that people who graduate from a bachelor's degree program who have some background in computer programming are often very much more attractive to hiring companies. And so, so we are finding that having courses that are specifically designed for non-majors, that are interdisciplinary or multidisciplinary in nature, are very, very popular. It turns out that's a good place to attract new majors as well. Computer literacy, it's used there, and pre-AP in high school. Now this is ALICE 2. ALICE 3, so this slide was prepared before ALICE 3. In ALICE 3, it is being used in CS1 courses. And so that we will talk about more. We have many, many textbooks for ALICE 2.2. One is not pictured here on this slide, and that's this one, right? This is the new one. This is the third edition of the Learning to Program with Alice book, and this has now, this is for ALICE 2.2, and this is now the #1 bestseller, all right, for introductory pre-CS1 kinds of courses. All right, in other words, college prep, okay, or at the college level for students that did not have programming in high school. The next question, that if I were sitting in your seat today, I would be asking is, does it work? Have you done any research to see if it works? Well, thank you for asking. Yes, of course. If you're going out to talk with people in industry and you're going to say, we need your financial support, or if you're going to, in the States we have something called the National Science Foundation, which is a governmental agency that provides funding for academic projects that they hope will be good for the science and math and engineering and technology programs in academia, in the colleges and universities, as well as the K through 12 schools. When you're going to go and ask for that kind of funding, you need to put up or shut up. You're not going to get the funding if you can't show that what you have is going to provide the potential for changing things, for making things better. And this is precisely what we wanted to do. I was very unhappy about students quitting computer science. Don't get me wrong. I don't think everybody should be a computer scientist. But I'd rather have them walk out the door saying, well, it's just not for me, than to walk out the door saying, You know, I didn't get it. I didn't understand it. I couldn't write doom. All right? I mean, what a reason. Have we done some studies? And yes, we have. Now, Professor Cooper, Steve Cooper, will talk in the internet conversation that we will have tomorrow. He will talk more about these studies. He will give you much greater detail than I have time to do today. But I do want to say that we have conducted now 2 studies. The first one was with Alice 2.2, and I have some slides here on that. This was conducted at Ithaca College, which is where I was teaching, and St. Joseph's University, which is where Steve was teaching. So that makes sense. And what we did was we did some historical work where we found that the students who were at risk of dropping out, of saying, I don't want to be this major. I want to change my major to phys ed or whatever. We typically found that those students who came in and had no previous programming in high school or were not ready for calculus, we would typically lose at Ithaca College and at St. Joseph's University, we would typically lose about 50% the very first semester. All right? And for those students who actually made it to the end of the semester, we found that their average grade in our CS1 class was a C. That is in about the 73 to 79th percentile in terms of grades. All right? So about a C grade. And if they did make it to the end of the class, only about 47% of those would go on and take the second semester, the CS2 class. So a huge, huge attrition rate, that is, dropout rate. When we took these students and put them into an Alice class first, and then had them take the CS1 class, we found that their typical grade went up 1 full letter grade, and not only that, but 88% of them were going on to take CS2. We did follow these students over several years thereafter to see if they made it through the entire semester. And although I don't have a slide on this, we found that about that this 88 percentile was persistent throughout the 4 years, and they made it through to graduation. So that really says something for the program. Now, do I have a few minutes to show the other one? Take me about 10 minutes? Yes? Okay. All right. Okay. So we have conducted a second study, and once again, this is something that Professor Cooper will elaborate on in his presentation. But we've been working now with Alice 3 within a CS1 class, putting it into the CS1 class, and having them take an exam at the end of the semester that is totally in Java. All right. Now the CS1 class is in Java in our study, and so they took a Java exam at the end of the semester, and it was the same Java exam as being taken in other classes that were straight Java. All right? It took us 2 years to work on the software development and the pedagogy development. We have been working for about a year and a half now to come up with the exam that would be tested and that sort of thing. The exam has these parts to it: expression evaluation, control structures, arrays of primitives, working with class definition, working with arrays of objects, writing your own class specification. These are the scores of students. Whoops, let me put this up. These are the scores of students no Alice. No Alice 3 in the CS1 course. One of the parts here that is probably most telling is that the total score, the average student score on this exam is 60.88. In our terminology, that's what we call getting by the skin of your teeth. Barely passing that exam. You had better hope you did well in the rest of the semester. All right? This was the test we did in the fall of 2009, where we instituted Alice 3 and Java together in the CS1 class. Same exam, okay, with a small change. We took some of the questions that were in part 6 and we integrated them into parts 4 and 5, and we changed the context from a GUI, graphical user interface of a clock, a digital clock, to a sports race with sailboats sailing to the finish line, an array of sailboats to get to the finish line, and you had to keep track of who won and that sort of thing. But it was equivalent in difficulty. We had it approved. And the average score on this exam for this class was, as you can see, 84.96. All right? Yes? Okay. And this is last semester. We did it again because we didn't believe the first time around. Too big a change. Scary is what that is. All right? We had 81.52. Very consistent, within reason results. All right? So does it work? Yes. Pure and simple. Thank you. Now, I think Professor Edson. Should I talk about talk about him? Yes? Okay. All right. This is the Alice mascot. Now, he's a Tigger, as in Winnie the Pooh and Tigger too. All right? Now, you may remember in the story of Winnie the Pooh, there was a character named Eeyore, who was always sad and depressed and never really happy. Yes? And then there was Tigger. And Tigger was bouncy, 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 everything. Yes? Okay? And he said, bouncy, bouncy, that's what Tiggers do best. Yes? Okay, when Randy Pausch was diagnosed with pancreatic cancer, he called me and he said, Wanda, would you please come to Pittsburgh? So I flew to Pittsburgh and met with Randy, and he said, you know, he said, I have something to tell you. And so he told me. And after I had cried for about 5 minutes, he said, okay, you can't cry anymore. I have cried many days with my wife, and I've decided that I can be an Eeyore, and I can continue to feel sorry for myself. Why me? Or I can be a Tigger, and I can bounce back, and I can help to prepare my family and my children and the members of the Alice team. So this little guy's name is Tigger, spelled T-I-G-R-R-R-R. Professor Edson.